Today we're going to practice solving systems of linear equations using the substitution method. So let's get started. We're going to look at three ways of solving systems of linear equations. There's the graphing method, and then there are two algebraic methods. So both substitution and elimination, well, these are going to be algebraic methods of solving systems of linear equations. The graphing method is great for introducing solving systems of linear equations because you can see how those equations, through the graphs of their lines, are related to each other, how they interact. Do they cross at one location? Are they parallel? Or do those equations represent the same line? But it's not as practical or efficient as these algebraic methods are. And as this sounds, instead of graphing, we're going to use algebra to solve systems of linear equations with these two methods. And I'm going to start with the substitution method because it may initially make more sense compared to the elimination method. So let's take a look at this substitution method. So for this first problem, we're asked to solve the following system by substitution. Notice I included this graph here. When you solve by substitution, you do not need to graph the lines. But let's take a look at what's going on with this system. So with our first equation, we have y equal to 2x plus 5. Our next equation is y equal to negative 3. Now whenever we have y equal to a constant, this is going to be a horizontal line. In this case, the horizontal line is crossing that y-axis at negative 3. So the solution to this system is where these two lines intersect. They intersect at the ordered pair negative 4, negative 3. Well, at least that's where they appear to on this graph. But let's find that solution using substitution. So we have y equal to 2x plus 5 and y equal to negative 3. So y is equal to negative 3. That means we can substitute this value into the other equation. So wherever there is a y in the first equation, we're going to replace it with a negative 3. This gives us negative 3 equal to 2x plus 5. Well, now we have one equation with one unknown variable. So we're going to solve for that variable. So to solve for x, we're going to first subtract 5 from both sides. This gives us negative 8 equal to 2x. And then dividing both sides by 2, we end up with negative 4 equal to x. And then I'll rewrite this as x equal to negative 4. So we have our x value. X is equal to negative 4. We already knew our y value of negative 3, so we end up with the ordered pair, negative 4, negative 3. So this is our solution to this system of linear equations. Let's check our answer by plugging that ordered pair into both equations. We should get a true statement for both equations. So we have y equal to 2x plus 5. That becomes negative 3 equal to 2 times negative 4 plus 5. So we have negative 3 equal to negative 8 plus 5. This gives us negative 3 equal to negative 3. So that's a true statement. Then with our second equation, we have y equal to negative 3. Well, y is negative 3, so we have negative 3 equal to negative 3. That is also a true statement. So when we solve systems of linear equations using substitution, the first step is going to be to rewrite one equation in terms of one of the variables. And then we'll take that equation and substitute that equation into the other equation. From there, we're going to solve the new equation and then find the value of the other variable. And as always, make sure you check your answer when you're done. So let's try these steps on a second problem. So we're going to solve the following system by substitution. The first step is to rewrite one equation in terms of one of the variables. Well, in this case, both of our equations are in slope-intercept form. So both of these are already solved for y in terms of x. So step 1 is already done. Next, we're going to substitute that equation into the other equation. So in this example, I'm going to replace this y in the second equation with 3x plus 2. Now you can also replace the y in the first equation with the expression negative x plus 6. Either of these is going to work. So when we substitute this in, we end up with 3x plus 2 equal to negative x plus 6. So what we have done is we have started with two equations and two unknowns. And we've ended up with one equation and one unknown. And this is what we want. Because if we have one equation and one unknown, in this case our unknown is this x variable, we can solve for that x variable. So I'll gather the x's, that x variable on the left side. That'll give us 4x plus 2 equal to 6. And then subtracting 2 from both sides, we end up with 4x equal to 4. And then dividing by 4, our x value is equal to 1. So we have solved the new equation. So the last step is to find the value of the other variable. So I'm going to take this x value of 1, and I'm going to plug this back into one of the equations. And I'll go ahead and plug it into this first equation. That's going to give us y equal to 3 times 1 plus 2. So y equal to 3 plus 2, y equal to 5. So we have the ordered pair 1, 5 as our solution. Let's go ahead and check our answers. So our first equation is y equal to 3x plus 2. So we have a y value of 5 equal to 3 times 1 plus 2. And then this is 5 equal to 5. That's a true statement. With the second equation, we have y equal to negative x plus 6. So this is going to give us 5 equal to negative 1 plus 6. Also 5 equal to 5. So our solution is the ordered pair 1, 5. With substitution, you do not need to graph the equations, but taking a look at this, we have the equation y equal to negative x plus 6, and the equation y equal to 3x plus 2, and they are intersecting, they are crossing each other at the point 1, 5. So that is the only ordered pair that these two lines have in common, and this is the solution to this system of equations. So let's try another one. So here we're asked to solve the following system by substitution. And we have a system of two linear equations. And in this case, our equations are not in slope-intercept form. They're in standard form. So neither of these equations is written in terms of one of the variables. We can pick either variable in either equation and solve for that variable. If we solve for a variable, it'll be all by itself on one side and everything else will be on the other side. You can choose either x or y in either equation. But what I like to do is if there is a variable that has a coefficient of 1 or even of negative 1, I'm going to choose that variable and solve for it. It makes the algebra a little bit easier. We don't have to divide by any of these coefficients and potentially end up with a fraction. So taking this second equation, we have x plus 4y equal to 8. I'm going to solve for x. So I'm going to subtract 4y from both sides. We now have x equal to negative 4y plus 8. Now we use that second equation. We rewrote the second equation. So therefore, I'm going to take this x value and substitute it in to the first equation. So the first equation is 3x plus 5y equal to 3. So now we have 3 times the quantity, negative 4y plus 8, plus 5y equal to 3. Using that distributive property, we get negative 12y plus 24 plus 5y equal to 3. Combining like terms on the left side, negative 12y plus 5y, that's negative 7y plus 24 equal to 3. And then solving for y, we're going to subtract 24 from both sides. We have negative 7y equal to negative 21. And then dividing both sides by negative 7, we end up with y equal to 3. So the first step was to rewrite one equation in terms of one of the variables. So we rewrote x in terms of y. We then substituted that equation into the other equation and then solved the new equation. So now we have to find the value of the other variable. We know y, we now need to find x. So we're going to take this value of y and plug it into this equation. This will give us x equal to negative 4 times 3 plus 8. We have x equal to negative 12 plus 8. X equal to negative 4. So our solution is the ordered pair negative 4, 3. So let's check our answer. We're going to take that first equation, go back to the original equations. So 3x plus 5y equal to 3. Just in case any mistakes were made when you were rewriting the equations, you always want to go back to the original equations. So we have 3 times negative 4 plus 5 times 3 equal to 3. This is negative 12 plus 15 equal to 3. 3 equal to 3, so that's a true statement. With the second equation, we have x plus 4y equal to 8. This is negative 4 plus 4 times 3 equal to 8. Negative 4 plus 12 equal to 8. And then 8 equal to 8. Again, another true statement. Now, when we use algebraic methods, we do not need to graph the equations. Again, it's a great way of helping to visualize what we're doing. So here we have the graphs of our two lines, and these are crossing at the ordered pair, negative 4, 3. This is the one point that these two lines have in common. And so our solution is the point, negative 4, 3. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So with this first problem, both of the equations were written in slope-intercept form. So in both cases, we have y in terms of x. So substituting x minus 7 from the first equation in for y in the second equation, we get the equation x minus 7 equal to negative 2x plus 5. So we've gone from two equations with two unknown variables down to one equation with one unknown variable. Solving for that variable x, we get x equal to 4. And then we can plug this value for x into either equation. I went ahead and used the y equal to x minus 7, resulting in y equal to negative 3. So our solution is the ordered pair for -3. Once again, don't forget to check your answer. For this second problem, both of our equations are in standard form. And in this first equation, we have two variables with a coefficient of 1. So we have 1x plus 1y. In this case, I went ahead and solved for x, resulting in x equal to 9 minus y. So next, I plug this value for x into the second equation, resulting in 2 times the quantity 9 minus y equal to -3. Once again, we've gone from 2 equations and 2 unknowns down to 1 equation and 1 unknown. Solving for that unknown, we get y equal to 7. And then with this y value of 7, I'm going to plug that into our x equal to 9 minus y equation. And we end up with x equal to 2. So our solution is the ordered pair 2, 7. And again, don't forget to check your answer. Drop any questions you have in the comments. Continue practicing solving systems of linear equations by substitution, and I'll see you in the next video.